This conference.
Okay, very good afternoon, dear participants of second year ECEA and B. I extend my warm welcome to all of you uh, to the new learning session on electromagnetic fields. So, as we sum up what we have done and what we are going to see today, what is our plan, etc. So, we have completed our first module yesterday. It is over. And we will be starting module 2, unit number 2 from today onwards. So before going into the slide of second unit, is there any volunteer who can revise what we have seen yesterday? Because we have seen yesterday some important 2-mark questions, a lot of theorems, a lot of statements, a lot of formulas. Okay, we have seen. So any volunteer to sum up what we have seen yesterday?
So we have seen about sources and effects of EM, sir, and Stokes
Okay.
definition and mathematical definition, sir. And then we have seen electromagnetic model in the two approaches, sir. That is inductive approach and deductive approach, sir.
Okay.
And then we have seen units and constants, sir.
Okay.
For electric field and also magnetic field. And we have seen two identities, null identities, and what is mean by Helmholtz theorem and mathematical definitions. And then we have seen extra two identities, sir, and proof for that identity.
Okay. Okay. Thank you, Divya, for your kind summarization. Thank you. Just for 5 to 10 minutes, we will go for questionnaire now. What are the different sources of electromagnetic radiations? Any volunteer can come into the line and you can tell the answer. See, once you have told the answer now, you please don't come again. For example, Divya has been given a chance now, so others can take up the chance because 90 students are there. Any one can tell. What are the different sources of EM waves?
So sun, mobile phone, television, and microwave oven and X-ray, sir.
Okay, super. Thank you, Anjali. Thank you for your answer. Also, somebody has chatted in the chat box, Ashmita, then Pavitra, yes, and all. So the answer is like sun, X-rays, mobile phones, television, then microwave oven as far as your kitchen appliance is concerned. All these things are sources of electromagnetic radiations. Okay. Next question, what are the effects or who will be the living things, living beings affected by these EM radiations? Humans, animals, plants, and birds. Okay. Gokilavani, Pavitra, Aishwarya, a lot of students have answered. Okay. Priyadarshi, living organisms. Okay, good. Totally she has living organisms. Okay. If you are unmuting yourself and if you tell the answer, it will be very good. Rather than putting it in the box, okay, text box. If you unmute yourself and tell the answer, it will be very good. Okay. Okay. So now we have answered. Next on, it comes to Stokes theorem. Can anyone tell the grammatical statement of the Stokes theorem? Grammatical statement. Otherwise, any statement, grammatical or mathematical, whatever it is. Yeah, anybody, you can unmute and you can tell the answer for Stokes theorem. State Stokes theorem. You have to start like Stokes theorem states that. In that way you have to start. Then you have to write the statement. Can anyone tell what is this statement?
The Stokes theorem states that the line integral of a vector around a closed path is equal to the surface integral of a normal component of its curl over any closed surface.
Okay. Mathematical statement, Aparna.
The integral of HDL equal to double integral of del into HDS.
Okay. You should not tell del into. It is actually del. What is that
Cross,
symbol?
cross.
Cross. Okay. Okay. Thank you, Aparna. Thank you. So EMF we have to differentiate between the terms. Okay. You should not tell del into del cross product, dot product, and gradient. These three are the basic operations. Okay. So thank you very much, Aparna, for your uh, response. Next comes units and constants. SI unit stands for
International System of Units.
Yeah, International System of Units. Good. Thank you, Pavitra. Pavitra is okay. Next, what is the unit of, for example, temperature? We have seen yesterday 4 things: length, time.
Celsius or Fahrenheit, sir.
Pardon? Yes, Aishwarya?
Celsius or Fahrenheit, sir.
Yeah, Celsius or Fahrenheit, degree Celsius or degree Fahrenheit. And what will be the normal temperature actually? Degree Celsius for a human body. Reference temperature in centigrade and in Fahrenheit. You can tell both.
98.6 Celsius.
98.6 degree Fahrenheit. 98.8, 98.4 and all is wrong. Karunaya has given and somebody else has given 98.4. Exact answer is 98.6 degree Fahrenheit. What about in degree Celsius? Yes, Gokilevani, you are right. What about degree Celsius? So it is actually 36.9 degrees Celsius. If you round it off, it is 37, but reference is 36.9 degrees Celsius. We can convert Fahrenheit into Celsius. You know the formula, right? 18 by 5 or 5 by 18, you have to multiply with the value so that you can get, make the conversion. Then what we have seen is, what is the relationship that is going to connect electric field intensity and electric flux density? Also we call it as displacement density, D and E. What is the relationship? D is equal to
Epsilon E, sir.
Epsilon E,
yeah,
sir.
D is equal to epsilon into E. What is epsilon is? It is the permittivity. Okay, permittivity. And what is the value of epsilon naught? Free space, vacuum, or air medium. What is the value of epsilon naught?
8.854 into 10 power minus 2, sir.
Yes, both Anjali and Priyadarshi have answered. Very good. It is 8.854 into 10 to the power minus 12. What is it, the unit?
Newton per meter, sir.
It's not Newton per meter, ma. It is Farad per meter. Okay, Priyadarshi. Newton per meter means it will become some other thing. It's Farad per meter. It's not Farad meter, Farad per meter. Okay, good, Priyadarshi, good. What about the relationship between B and H as far as magnetostatics is concerned? B is magnetic flux density and H is magnetic field intensity. B is equal to
Mu H, sir.
Mu H.
B is equal to mu into H. What is the value of mu? What is mu is actually, it is the permeability. Permittivity for second unit, and for third unit it is said to be permeability. What is the value of mu is? Mu is equal to mu naught into mu r, where mu naught is the permeability of free space or air or vacuum, and mu r is the relative permeability of the medium. Okay, can anyone tell what is the value of mu naught, air medium or vacuum medium?
4 pi into 10 to the power minus 7.
4 pi into 10 to the power minus 7
Henry per meter.
Henry per meter. Okay, very good. So 4 pi into 10 to the power minus 7 Henry per meter. Okay. What about the two approaches that are available in electromagnetic model? Two approaches.
Inductive approach and deductive approach.
Inductive approach and deductive approach. Okay, super. Okay, now comes the last question. Null identities we have seen already, right? The statements we know, but the mathematical null identities we know. Kindly you try to practice to make it as a statement. For example, del cross del v equal to 0 is a statement. Del cross del v is a statement. That means del cross means curl. Okay, curl of del v is gradient. May right? That is equal to 0. In that way, you have to write. In the same way, del dot del cross h is equal to 0. That also is an identity. You kindly take del dot del cross h actually. So first of all, del dot, that means divergence. Divergence of the curl. Okay, that is equal to 0. In that way, you have to write. Okay, last question. What is meant by Helmholtz theorem? Helmholtz theorem statement. General
Helmholtz
vector
theorem
function
states
F is
that a
equal
general
to, yes. Yes, Anjali, you
minus
can
del v
continue.
plus del cross A, sir.
Yeah, minus del V plus del cross A, where A is any vector, del V is the gradient of potential gradient actually, or gradient of any scalar value is del V, and del cross A is nothing but A is any vector. For that, if I take curl, the summation of these two values will give us the value of general vector function. We call it as F, capital F. This is what is Helmholtz theorem states. Okay, very good, Anjali, very good answer. Okay, with this particular view, we will close our unit number 1 and we will go to unit number 2 now. Okay. Any doubts you are having in unit number 1? Anybody? No. Okay. So no doubts. Okay. Thank you, Divya and Pavitra, for your kind response. Now I will share the screen of unit number 2, PPT. I share the screen. Okay, good. Yeah, is your screen visible?
Yes, sir, visible, sir.
Okay, thank you. So fine, it is unit number 2. Unit number 2, the title, unit title is Electrostatics. Electrostatics. And in this particular unit or module, we are going to cover today, this PPT has got electric field and Coulomb's law, these two things. Okay. Have you studied Coulomb's law already? Anywhere? Might be in 6.
Yes, sir. In 12th, sir.
Okay, okay. What is Coulomb's law? We will see it later. Just I want to know whether I have studied already. Okay. Agenda for today, it actually looks like this. Revision of the previous class. So what we have seen till now is the revision of the previous class, and this time we are focusing towards the second unit, electric field and Coulomb's law. Okay. Then we will go for charge distributions based on the time limit. We will move on to that, and then we will finally summarize. As far as course outcomes are concerned, okay, before going to this slide, let me change this slide. Yeah, can anyone tell me what is CO1? The statement of CO1?
The understanding of fundamental electromagnetic laws and concepts.
Okay, very good, Divya. See, always you keep memorizing these COs. At the end of each and every unit, every module, I will ask some random numbers to tell these COs, because COs you should memorize. Okay, then only you can understand why we are doing this particular module, why we are learning it. That meaning will come to you. Okay, so good. I'll call somebody from Easy B also. From Easy B, anybody can tell what is CO1? It is open to you. What is the statement of CO1? Course outcome 1. Yes. Can I get Merlin Anita online? Merlin Anita, are you there in the link? Okay, Pavitra. Pavitra is. Okay. Any other student volunteer from A section? What is CO1?
Sir, understanding of fundamental electromagnetic laws and concepts.
Okay. Okay. Thank you, Renuka Devi. Understanding of fundamental electromagnetic laws and concepts is the actual CO. Okay. Now we will go for CO2. So you start memorizing CO2 from today onwards. Okay, see, CO2 and CO3 both will look alike. Only thing is, instead of static electric field in second module, you will be having static magnetic field in this third module. That is the difference. So CO2 is analyze field potentials due to static charges and static electric fields. Analyze, it is under K4 level. Analyze field potentials due to static charges and static electric fields is the actual CO. Okay, so this is the unit content of second module. So second module is completely dealing with uh, electrostatics. So unit title is electrostatics, and the subtopics are like electric field, Coulomb's law, Gauss law and its applications, electric potential, conductors in static electric field, dielectrics in static electric field, electric flux density and dielectric constant, boundary conditions, capacitance, parallel cylindrical and spherical capacitors, electrostatic energy, Poisson's and Laplace's equations, current density and Ohm's law, equation of continuity and Kirchhoff's current law. So these are the different topics that are available in module 2, and we are focusing towards electric field and Coulomb's law because first of all we will start with this, and one more point I want to convey: your CAA1 is fastly approaching. So topics or syllabus will be 1.5 units. So first unit we have completed comfortably. Second unit, at least half portions or whatever portions I am covering it, that will be the portions for our course as far as CAA1 is concerned. Okay, at any date it is starting. You kindly make a note of it to whichever points or topics we have covered. That will be the portion. Okay, in this unit, as you look at the syllabus, it looks very vast. Okay, but I'll teach you very simply. Okay, you kindly cooperate with me so that you can understand and complete this particular unit very easy. Okay, this unit and the third unit more or less both will look same. Only thing is here in second unit electrostatics, we will be actually deriving the expressions for D and E, and then electric potential for different geometries. But in third unit, what happens is you will be deriving the expressions of H and B for different geometries. Okay, that is the only thing, but the approach is same. So what approach we are actually following it for these geometries to derive electrostatics, the same approach you can do it for magnetostatics. So if you deal with the second module comfortably, you can easily touch the third module without any hesitation, right? That is what is the point I want to tell. Okay, so this is the unit content of unit number 2. Let me go to next slide. Yeah, first we will start with what does electrostatics. What is electrostatics, right? So it is nothing but electrostatic. It provides three-dimensional understanding of electricity and magnetism. See, electricity, first of all, it deals with electrostatics. Electrostatics means the static charge and dynamic charge. Both are available. Static charge means a charge which is not moving, which is kept stationary. Dynamic charge, which is in motion. Okay, that's the difference. And electric and magnetic fields forms a bridge from circuit theory to the transmission lines, waves, and wireless systems. See, you will be studying transmission lines and waveguides, then transmission RF signals like that. In future semesters, you will be studying these papers actually. Okay, so for these papers, our Maxwell's equations, whichever we are doing it in our fourth module, and the circuit theory basics, those things will form the base. That is why these fields, these concepts of electrostatics and magnetostatics, it forms a bridge from circuit theory to TLRF. TLRF is nothing but transmission lines or transmission waveguides, we call it as, or we call it as transmission lines on the RF radio frequency, like that. For future semester papers, it will be helpful. How radiation, electromagnetic radiation or wave is going to travel. Okay, that's what is that particular paper. So it is nothing but a 3D understanding of electricity. That is what I'm going to call it as electrostatics. Okay, so sources of the electric field or electric charges, we know that, and the strength of the field at any point depends on these four parameters. Number one, its magnitude. Number two, its position. Number three, its speed, that's its velocity, and finally its acceleration. So sources of electric field are nothing but electric charges, and the strength of that particular field depends upon four parameters. Number one, magnitude. Number two, position. Number three, velocity, and acceleration of the charges involved. An electrostatic field is a field. This is the definition for electrostatic field. It is a field in which the sources are stationary. Electrostatics means sources are stationary, only the magnitude and position of the charges will be considered. What is the value of the charge and where it is placed in the space, position, those things will be considered for the electrostatic fields. The only thing is the charges, or I can say sources, will become stationary here. You have to understand this. Electrostatic field is a field in which the sources are stationary, only the magnitude and position of the charges will be considered, because that particular position and magnitude only will be considered for Coulomb's law. If you recall the definition or statement of Coulomb's law, you can understand. Okay, we will see in the future slides. Next, all these 5 slides or 6 slides, I will be covering first the basic terminologies, whichever is available here. Okay, so we started with what is electrostatics, then what is meant by electrostatic field we have seen. Now we will focus towards what is electric flux. Electric flux is nothing but this particular symbol is used for representing electric flux. What is this symbol named? Can anyone tell what is the name of this particular symbol?
Sigma, sir.
No, Bharani Lakshmi, this is not sigma.
Psi, sir.
What is it?
Psi.
Psi. Yeah, Priyadarshi, you are right. Yeah, so many members have chatted in the chat box also. So it is psi. ஓகே, பார்க்கிறதுக்கு பாத்தீங்கன்னா திருப்பதி திருநாமம் மாதிரி இருக்கும் கேட்டா, அதுக்கு பேரு வந்து சை. ஓகே, so here actually if what is meant by electric flux, what is meant by electric flux means, 1 minute. Okay, so if a test charge, I'll be having two charges, you assume it. One I am calling it as the main charge, capital Q. Another small q, I am taking it as a test charge. I am taking it as a test charge. And here what I am doing is, if that particular test charge small q is moved towards the main charge capital Q, what will happen is that particular test charge small q will experience a force. Okay, will experience a force due to the main charge, capital Q. Main charge capital Q. Is it okay? The lines of force can be designated as electric flux, which is equal to the charge itself. Okay, have you got the point? That is, I am having a main charge capital Q somewhere. Okay, and I am having this particular, I am going to bring this particular test charge small q somewhere. Okay, I'll do some other thing so that you can understand. Yeah, here you can see I am having a capital Q somewhere here. Okay, somewhere here, that is somewhere here it is there. Okay, and I am having a small q, that is my test charge. Okay, test charge somewhere here. Okay, what I am doing is, if I am trying to bring, okay, if I am trying to bring this particular test charge towards the main charge, okay, what will happen is actually this particular test charge will experience a force. Okay, that particular line of force, we call it as what, electric flux. We call it as electric flux. That is what they are going to tell you, nothing else. And the magnitude or the value of that particular electric flux psi will be nothing but the charge itself. That is my q value, capital Q is there now, that particular value itself. That is what they are going to tell us. Okay, so that is what is this particular point. Okay, fine. You got the point, no? Electric flux side. Next is the electric flux density. Electric flux density. It is very simple. See, normally what we call it as current density. Can anyone tell what is meant by current density? சும்மா கெஸ் பண்ணுங்க, கரெக்டா இருக்கணுங்கிற அவசியம் இல்லை, கெஸ் இட். See, normally current density and the mari, yeah, you are right, Renuka Devi. Bharani Nagalakshmi, you are wrong actually, slightly wrong. Okay, I can correct it, no problem. See, what is current density means? It is nothing but current per unit area. Area you have to put Bharani Nagalakshmi. You have given it as volume. It should not be volume actually. It should be area. That is current flowing per unit area, that we call it as a current density. In the same way, flux density, or the other name is displacement density, notation is capital D, is defined as electric flux per unit area. See, always flux density is the term that's coming out here, means current density, like that. If it is coming, means it has to be divided per unit area. So notation is electric flux. We have now only we have seen its notation is psi, and it is equal to charge itself, that is we have seen. So Q itself, so it can be written as Q by A. What is the unit of charge? It is Coulomb. Unit of area is meter square or square meter. So unit of electric flux density or displacement density is Coulomb per meter square. Coulomb per meter square. Okay, for example, I am taking a particular geometry called sphere. So what is the surface area of a sphere? You consider that the sphere has got a radius of r. The radius of the sphere is r. So what is its surface area? Surface area is 4 pi r square. We know that already. 4 pi r square. Okay. So what happens to my displacement density? Q by A. So it becomes Q by 4 pi r square. Sorry. Now we have derived the expression for D. Okay, we know already that the relation between D and E is D is equal to epsilon into E. D is equal to epsilon into. So what happens to the E value is E is equal to D divided by epsilon. D divided by epsilon. So what happens for this particular sphere? It becomes E is equal to Q divided by 4 pi epsilon r square. E is equal to Q by 4 pi epsilon r square. Do you understand what I am telling? Any doubts till this particular portion? Okay, no doubt. Thank you, Pavitra, Anjali, Gokilavani, Aparna, all these guys. Thank you so much. So what we have seen or covered till now was the basic terminologies of electrostatics. We started with what is electrostatics, then we have seen the definition of electrostatic field, then we have entered what is electric flux. Next to it, what we have seen is electric flux density. Okay. Now we will go for Coulomb's law, the second part of today's class. So Coulomb is actually the scientist name which is shown here. He is actually Charles Augustine D. Coulomb. His full name is Charles Augustine D. Coulomb. So Charles Coulomb, what he actually observed from his test is he has derived the expression of force exerted or experienced between two objects, each of which is having a static charge. So between two objects or two charge carrying conductors, okay, how much will be the force experienced? That is what he has tested. So this particular law named after his invention, like Coulomb's law. Charles Augustine D. Coulomb is the scientist name. Okay, what he stated actually, very important 2-mark question and big question also sometimes. Coulomb's law states that, yeah, Pavitra, yes, you have given the answer, very good. Its grammatical statement is Coulomb's law states that the force between two very small objects, but the condition is both should be current carrying or both should have got static charges. Two very small objects separated by a distance which is large when compared to their size is directly proportional to the charge on each object and inversely proportional to the square of the distance between them. This is what he states. Do you understand? I am having two small objects which are separated by a long distance. The point how they have given it is the size of the object is very small when compared with the distance separated. If that is the case, Coulomb's law is applicable, and he stated that for such a geometry, the force will be directly proportional to the charge on each. For example, in the first object, if I am having Q1 as charge, and in the second object, if I am having Q2 as the charge, right? They are proportional. Force is proportional to directly proportional to the charge on each. So it is proportional directly to F is proportional to Q1 and Q2. That means Q1 into Q2 and is inversely proportional to the square of the distance between them. If the distance separating these two objects is R or D, for example, then it becomes D square. Is it okay? So that is what Coulomb's is stating actually. That is, if I want to write it like the Coulomb's law, what happens? I will write it here. For example, if I am having two charges, let us take Q1 somewhere here. See, these two charges are very small. You can see it, right? If I am having Q2 as another test charge somewhere here, you look at these things. You assume that these two things are separated by a distance. Let us take D, small d or R, whatever you like, you can assume. So you can see here d value, distance separation, is much larger when compared with the dimension of the object. Okay, so for a dot you will have negligible radius actually, or diameter, but this distance is very large. If this is the case, then Coulomb found that F, force exerted, will be proportional directly to the charges on both the objects. So that is proportional directly to Q1 and Q2, or I can write proportional directly to Q1, Q2, and he found like that particular force will be proportional inversely to square of the distance between them. So it becomes 1 by d square. So what will happen if I combine these two terms? What will happen? I can write F, I can write force proportional to what I can write in the numerator. It is Q1 into Q2 divided by, I can write d square. So this is what is the statement of Coulomb's law. Do you understand what is Coulomb's law? Yes or no?
Yes, sir.
Okay, so this is what is my Coulomb's law. Coulomb's law states this thing only. Okay. Next, what do you mean by the term point charge? So now I have assumed Q1, Q2 in my example. Yeah, those two are said to be point charge. Point charge is also called a dot. dot charge. So it is an important 1 mark question or a 2 mark question. What is meant by point charge? Point charge is a small charged particle which is having negligible dimension. Its radius or its diameter cannot be measured. We cannot measure them. Okay, in that way, it will have very negligible dimensions. That will be called that we call it as point charge or dot charge. So now I have drawn Q1, Q2. Yeah, those two we can call it as point charges. No issues. Next, Coulomb's law in some other fashion they are giving it. See, actually, force experienced or exerted between 2 point charges, he has stated. That particular force will have what we call it as force of interactions. See, this particular force of interaction can be either a repulsive force or otherwise it can be attractive force. Okay, when the force of interaction will be repulsive, you know already, like poles repel, unlike poles attract each other. This particular thing you know, right? So repulsive force, when we will get this force of interaction to be a repulsive one, means if when both the charges are like, it will have a repulsive force, and the force of interaction will be of attractive in nature when both the charges are unlike. Unlike means opposite. For example, the polarity also matters, plus minus. Okay, that also matters for Coulomb's law. Okay, next one. Again, the same statement they are giving it, but in terms of force of attraction or repulsion, they are telling it. Coulomb's law can also be stated as the force of attraction or repulsion, or generally we can tell like the force of interaction between any 2 point charges is directly proportional to the product of 2 charges and inversely proportional to the square of the distance between them. That is what we have seen actually. Okay, this is the Coulomb's law. Yeah, this is what I have written. Consider the 2 point charges Q1 and Q2 separated by a distance r. The force of interaction between 2 point charges is given as follows: F proportional to Q1 into Q2 and F proportional to 1 by r square. So if I combine these two, hence the force can be written as F proportional to Q1 into Q2 by r square. Okay, it is proportional actually. If I want to eliminate that proportionality, I have to put a constant there. Okay, so force will be written as F is equal to Q1 into Q2 by 4 pi epsilon r square Newton. Unit of force is Newton, where epsilon is the permittivity of the medium or the dielectric constant. I can say permittivity of the medium, or we can say it as dielectric constant, where epsilon is nothing but epsilon naught into epsilon r farad per meter, and epsilon naught's value we know already, it is 8.854 into 10 to the power minus 12 farad per meter. Epsilon r is said to be the relative permittivity of the medium, whose value is 1 for vacuum or air medium. Okay, that is what is the point. Yeah, everything I have told. Relative permittivity, we can find it as epsilon r is equal to epsilon by epsilon naught, or it can be defined as the ratio of the permittivity of the medium to the permittivity of the free space or vacuum, whose value was 8.854 into 10 to the power minus 12 farad per meter, or its equivalent value was 1 whole divided by 36 pi into 10 to the power plus 9 farad per meter. See, நம்ம ப்ராப்ளம் சால்வ் பண்ணும் போதெல்லாம் பாத்தீங்கன்னா நம்ம 8.854 10 to the power minus 12 விட 1 by 36 pi into 10 to the power plus 9 எடுத்துக்கிட்டோம்னா நமக்கு ஈஸியா இருக்கும். ஏன்னு சொல்லுங்க பார்க்கலாம். ஏன் ஈஸியா இருக்கும்னு சொல்றேன்? 1 by 36 pi into 10 to the power plus 9 எடுத்துக்கிட்டா. Why it is easy means, you look at the previous slide. Here force பாருங்க Q1 Q2 by 4 pi epsilon r square னு வருது இல்லையா? முன்னாடி ஒரு 4 pi இருக்கு. இப்ப நான் epsilon naught அப்படிங்கிற இடத்துல if I put it as 1 by 36 pi into 10 to the power plus 9, what will happen? Pi cancels, 4 and 36 can be cancelled and we can write it as 9. இல்லையா? அந்த சிம்பிளிசிட்டிக்காக தான் சொல்றேன். இல்ல if you are convenient to substitute it as 8.854 into 10 to the power minus 12 itself அப்படின்னா you can continue with that, no issues. இதுதான் போடணும் கம்பல்சரி கிடையாது, you can even do that. Okay, so this is what is Coulomb's law. Tomorrow we will see the next portions, like in vector form how to represent, what is principle of superposition, then charge distributions, everything we will do it in the next class. Any doubts till this particular slide? இந்த ஸ்லைடு வரைக்கும் யாருக்காவது ஏதாவது டவுட் இருக்கா? No. Okay, then I will stop sharing the screen. And we will close our meeting now. We will meet again on Saturday, first hour, 9:30 to 4:30 class. There we will discuss Coulomb's law in vector form and other portions. Along with that, we will see problems from Coulomb's law. Along with that, if time permits, we will cover Gauss law also, the next portions. Okay, so we will meet once again on Saturday from 9:30 to 10:30. Thank you so much.